We got a gander at a couple of dazzling pictures as the James Webb Space Telescope, JWST, peers back around the beginning of everything. The James Webb Space Telescope has uncovered a revelation that challenges the outer layer of our comprehension. This new disclosure has provoked the curiosity of cosmologists and researchers, recommending a possibly gigantic occasion that could change the universe as far as we might be concerned. The finding is influential for such an extent that it raises worries about the underpinning of our cosmic presence. Might this disclosure at any point at last prompt the finish of all we be aware? Is the universe approaching the actual edge of an exceptional occasion past our ongoing comprehension? Join us as we investigate the most recent disclosure of the James Webb Space Telescope and how it could shape the universe. When we look at the edge of the universe, we start with a detectable universe. It resembles seeing through a window into the district past what can be recognized. The discernible universe envelopes all that can right now be seen, estimated, and dissected with our telescopes and space missions. It is an assortment of stars, universes, and heavenly bodies that are noticeable to us. In any case, the perceptible universe is just a piece of the entire universe, a little piece of a huge grandiose pie that people can survey and see. However, the general size and nature of the universe stay a mystery. The width of the noticeable universe is around 93 billion light-years. This figure is the aftereffect of different variables, including the distance that light can go in one Earth year, 9.46 trillion kilometers or 5.88 trillion miles. A light-year is the distance gone by light, the quickest thing known to man, in 1 year. The assessed age of the universe since the enormous detonation is 13.8 billion years. This implies that light transmitted by objects in space that we can see has been going toward Earth for almost 13.8 billion years. This recommends that the recognizable universe is 13.8 billion light-years toward each path from Earth, making it 27.6 billion light-years in diameter. However, Hubble's regulation expresses that space has been extending since the enormous detonation, and hence the perceptible universe has been developing. Evaluations of this development demonstrate that protests that discharged light 13.8 a long time back from a distance of 13.8 billion light-years are currently a lot farther away, around 46 billion light-years from Earth. This implies that the discernible universe expands in excess of 46 billion light-years toward each path from Earth and has a measurement of around 93 billion light-years. So, when we say the detectable universe is 93 billion light-years wide, we are discussing a mind-boggling field. Around 13.8 quite a while back, a colossal blast happened, what began what we currently allude to as the development of the universe. Since that underlying second, the universe has not exclusively been growing yet, in addition speeding up. Complex powers, as strange dim energy, seem, by all accounts, to be driving this speed increase, pushing the universe's limits at any point further apart. As the universe extended, matter started to frame under the draw of gravity. This gravitational fascination united particles, bringing about the arrangement of shocking designs like stars, worlds, and ultimately planets, including our own dear Earth. Given the universe's steady development, the perceptible universe grows by another light-year each Earth year. Simultaneously, light from farther items keeps on arriving at Earth. Interestingly, this implies that we are seeing continuously a greater amount of the universe over the long haul. While we will always be unable to notice the whole universe from Earth, the field of perception is constantly expanding. Advances in innovation catch and examine electromagnetic radiation past the apparent reach, permitting us to find and view far-off individual cosmic systems, bunches, and superclusters in the discernible universe. Explicit telescopes, similar to radio telescopes, X-beam telescopes, bright telescopes, infrared telescopes, and others, have been useful in such manner. The exceptional Hubble Space Telescope and the James Webb Space Telescope have empowered the perception of the primary stars and cosmic systems that arose in the recognizable universe, making these miracles more available to the public. Despite its boundlessness, the universe is oddly unfilled. Regardless of whether we diminished our whole planetary group to the size of a quarter, the closest star would in any case be around 2 soccer fields away. This tremendous void broadens even inside our own smoothway world, which is one of billions in the perceptible universe, providing us with a feeling of the universe's huge scale. You may be inquiring as to why we can't simply see everything in the universe. There are different purposes behind this constraint. Albeit light is the quickest object in the universe, it actually requires investment to go through space. This implies that when we take a gander at far-off objects, we are basically Thinking back in time. The farther away an article is, the more its light has gone to contact us. It resembles glancing through an immense time machine, disentangling the historical backdrop of our universe as we witness cosmic systems millions, in the event that not billions, of light years away. However, there is one more variable at play: the universe is extending. Envision the outer layer of a swelled inflatable canvas it recognizes. The spots move separated from one another as the inflatable grows. The universe follows a similar rule. Worlds float separated as the texture of room extends. The light radiated by far-off objects goes through a shift known as redshift because of this extension. Light frequencies are extended, with objects moving away moving to longer frequencies, normally seen as a rosy variety. A few heavenly bodies ultimately pass past a basic distance known as the infinite skyline, where their light is essentially excessively far away to contact us due to the universe's growing nature. Given these two focal variables, the light's process through time and the development of the universe, it's nothing unexpected that we haven't seen the whole universe yet. Indeed, even with the most exceptional telescopes and innovation, our vision stays restricted by the crucial qualities of the universe. Let's dive somewhat more into these ideas. The universe's size is faltering. Specialists use estimations like light years to mean the distance light goes in a year, roughly 5.88 trillion miles or 9.46 trillion kilometers. Our system, the smooth way, is around 100,000 light-years across. Indeed, even inside our system, the closest star to our Sun, Proxima Centauri, is around 4.2 light-years away. At the point when we notice space, we can see systems billions of light-years away. This implies that the light we see from those worlds started its excursion billions of years prior, giving us a brief look into the universe's initial history. The secret of the universe's edge and the journey to comprehend its potential cutoff points definitely stand out of numerous across different fields. While conclusive responses keep on escaping us, three significant speculations have arisen, each offering a special point of view on the endlessness of room. The primary hypothesis places that the universe is boundless, with no evident end. This thought lines up with the cosmological standard, which expresses that the universe is isotropic. Its consistency and appearance are something very similar from each vantage point. In the event that this thought is valid, it recommends that the universe has no limits and can extend unendingly in all directions. The second hypothesis offers an elective view, contending that while the universe might be limited, it comes up short on unmistakable edge. Rather, it is contrasted with an immense bended space, similar to a globe. In this situation, if one somehow happened to go toward any path perpetually, they would ultimately get back to their beginning stage, similar as circumnavigating the Earth. The third hypothesis, the multiverse speculation, presents the entrancing thought that our universe is only one among many. Envision incalculable universes, each with its own arrangement of actual regulations, constants, and qualities. These universes might be totally unique and work freely of one another, or they might be interconnected through complex frameworks, shaping a gigantic and many-sided multiverse. Exploring these speculations flashes both logical and philosophical interest. The idea of an endless universe challenges our thoughts of room and our view of its boundlessness. Then again, a limited universe without an edge difficulties our thoughts of cutoff points and development, proposing the chance of repeating designs inside the texture of room. The multiverse speculation, with its equal universes, offers a rich scene for investigation, proposing the presence of domains immeasurably not the same as our own. If valid, it would suggest that varieties in actual regulations and key constants could prompt completely various types of presence, opening up a universe of potential outcomes past our ongoing understanding. However, these thoughts stay hypothetical and tricky. Exploring the universe's edge includes critical difficulties. It is challenging to absolutely demonstrate or refute these hypotheses because of the immensity of enormous space and the impediments of our ongoing observational devices and innovation. The revelation of the universe's edge has been a charming excursion, wealthy in hypothesis and reflections. However, one wonderful device, the James Webb Space Telescope, JWST, stands apart as an encouraging sign, uncovering bits of knowledge into the secrets that cover the universe's starting points. This phenomenal instrument can possibly reveal the secret history of our universe, permitting us to acquire information a long ways past what was beforehand imagined. The JWST is a specialized wonder, explicitly intended to notice the universe with unmatched accuracy. Its extraordinary elements empower us to look into the starting points of the universe. The JWST has found huge cosmic systems that date back between 500 million and 700 million years after the enormous detonation, as per late exploration distributed in N.